right. Oops. I'm gonna do that. Welcome to the Godot Coding Challenge episode number one. Today we're gonna cover the Starfield screensaver effect. I'm sure you're probably familiar with it, but for those who are not, it's basically just a black background with a bunch of stars, and those stars approach the viewer. So um, as you can see, they all start off far away and towards the center, and then as they approach the camera, they kind of fly off towards the side. They get a little bit larger, and you can also see a little bit of a trail. This trail kind of gives the illusion of quick movement. It's a cool effect, and we'll try to implement that as well. So this is based off of the first episode of the Coding Challenge by the Coding Train channel. I highly recommend you check it out. Probably better to check that out first. It's a bit more uh, easy to follow since it's not using the Godot Game Engine. But for those who are familiar with Godot, we're going to try to implement the same effect in the engine itself. Um, it's also good to have the Godot documentation up and ready to go. You can find that just at godotengine.org, and then they have a link to the latest documentation. Today, we're going to be really using the CanvasItem node. That is an item that can draw itself on a canvas. It's mostly used by controls in Node 2Ds, which is basically meant for displaying things in two dimensions, controls being for GUI related things, and Node 2Ds being for 2D game objects. But the main advantage that CanvasItem gives us is that it has these draw functions. So there's a draw virtual function that we can implement to draw the shape itself, and also a large number of various draw functions that we're not really going to use. We'll probably just use draw circle, and we'll probably go over draw line to draw the tail of it. So looking at this screensaver, we can see that it's basically only one sort of object we're worrying about, and there's just a whole field of them. The object being a star that exists somewhere on this 2D plane, and the star can start at a distance far away, and then it approaches the camera, at which point it moves off to the side, speeds up, and grows in size, which gives the illusion of it moving towards us in 3D, but in reality, it's all just going to be 2D um, 2D sprites, or not even sprites, but 2D shapes that are being drawn onto this canvas. Um, but I think to start, we'll just make a object that can exist in this 2D plane, and then we'll try to make it so it can move towards the camera, and then once it reaches the end of the camera, it'll appear back at the start and repeat the process. And finally, we'll try to draw a trail on it so that way it gets this cool little movement effect that that we're seeing here. So to start, I have Godot up and ready to go. We're going to create a new project. I'm just storing it here in a temporary folder, but I highly recommend that if you wish to follow along, you include this in some sort of version control or something that you can keep track of yourself so you can look at it in the future, make improvements, review what you did, and overall just get it in a more official context than just a temporary folder. So let's make it and call it Starfield. We'll create the folder. Oh, it already exists. We'll delete this old one. And I will note that I have done this before. Let me delete it in Explorer. I have done this in the past, so I'm not doing this completely blind. I highly recommend that you try it out yourself without copying any code. Don't, oops, wrong folder. Don't copy and paste anything. In fact, the more that you can type on your own and not even copying what you see on the screen, the better. That'll just help you learn it faster, and you'll retain the knowledge a lot better than copying any of it. So let me find this documents and go temp, and we'll delete these old ones. All right, and we'll go back up. All right, so we're gonna close this, create a new project, create the new folder in here, create and edit, and we're gonna come up with a blank project. So, oops, that's fine. So let's make a new 2D scene. We're gonna make something that is our star. So we're going to leave it as a node 2D just because it is a two-dimensional game object, but we're not really going to use most of the 2D attributes, most specifically the transform, z-index, visibility stuff. We're going to leave that alone for this project. we're actually going to control the position of where we draw things in the script itself instead of using all of the Node2D transform. We might be able to take advantage of just the canvas item directly, but for the sake of this, we're going to leave it as a Node2D since that keeps things a little bit easier, and then just take advantage of the canvas item that it inherits from to make it work. So once we have our star, let's create a script. So we will add a script to it. We'll just call it the same thing, star.godot script, create. And now we have our basic script to start working with. So let's do the first step. Let's make something that exists somewhere in the canvas. We'll give it an x, and we'll just do them both at the 0, var y equals 0. And we'll also give it a radius, and this will be the default radius at the basically the center of its trajectory. So if at 0 it's really far away, and at 1 it's close to us, or maybe it's easier to do it the other direction. Let's say 1 is really far away, and 0 is as it's approaching the camera. We'll let the radius adjust based on that distance factor. So let's just call a radius. We'll start with, let's do 5 for now. And distance factor, we'll pick a number here, but for now, let's just do 0.5. We'll worry about that later. So where does this exist in the canvas? And finally, how big to draw the star? Okay, so we've got our x and y and a radius. The first thing we're going to do is just simply draw. We're not going to worry about moving it. We're not going to change the size of it. We're just going to draw this circle somewhere on the canvas. So to do that, you just have to call the function update. What that is going to do is that's actually going to call another function that we need to implement called draw. And we can do all of the draw logic here. So draw the circle for the star. To do that, we can go back to our documentation and see, oh, let's do a draw circle function here. So we can just call draw circle. It takes a position, radius, and a color. So draw circle. The position is going to be the vector 2 of the x and the y. The radius can just be radius for now. And finally, the color is we can do color, and we'll just give it white. So 1, 1, and 1. So that says draw a white circle at this radius at this position. And that should be all we need to worry about. So let's save the scene, start at tscene, and let's run it. So we can see here in the top left corner, we've got our star. Remember, we're drawing at 0, 0. 0, 0, the origin is here in the top left. So we're only seeing this kind of bottom right quadrant of the circle. But once we put it in the right position, it's going to move around. In fact, just for default, we can do something like 50 and 50, and we'll run that. And we'll see that the star is drawn 50 pixels in from either side. So there's our star. So this is the default size. So right away, I know I want it a little bit smaller. Don't need the stars to be big. And we'll move this back to 0 just so that it's in the right position. So now that we have our star at an x and a y, we want to be able to move it based on some distance away that it is from the camera. So let's make a new variable to track the distance of the star. And we'll also want to be able to track the speed of the star so that way we can animate it moving towards the camera. So we'll do var z as our distance equals 0. We'll start it at 0 for now. In the future, we'll make sure it gets to the right position. And then we also want to call something called speed, var speed, and we'll call it 200. It doesn't really matter. It's an arbitrary unit anyway, so we'll just pick 200 for now. So it's going to start at a speed of a z of 0 and a speed of 200. And then, 1 second, sorry. And then what we're going to do is start animating it. So what we can do now is this update is only being called during ready, so it's only going to update its drawing once. We want to be able to update it every single frame. So let's move this out, and instead we want to do a set process to true. And what that means is it's going to now process this node every single frame, which is what this function that's commented out here is doing. So we can now uncomment that. So every frame we're going to call this process. The delta is the time between the previous frame and this frame. I won't go into too many details on that, but we'll use the delta to adjust the speed to make sure that it's not dependent on the frame rate for how fast it animates. So what we're going to do now is we need to, excuse me, we need to update the distance away. So if we recall correctly, we're going to determine that, or we're going to define that the depth of 1, the value 1, is as far away as possible. And then as the depth decreases towards 0, or not, let's say not 1, but whatever the max depth away is far away. And then as it decreases towards 0, that's it moving towards the camera. So what that means is that we need to decrease the distance every frame based on the speed adjusted by the delta. So we can do that simply by just calling a distance equals the speed. This is the distance that it moves, is the speed it's moving times the frame delta. And then we can just tell Z to minus by that distance. So now we are adjusting the distance every frame. Because the star has moved position, we also want to update the drawing of it, the star, and we can just do that by moving that update function that we were calling before into process. So this says every frame adjust Z and then update the drawing, which then calls this draw function. And then that will simply move it, but as we will see, because we're just drawing the circle based on the X and Y, it's still up here in the top left and it's not actually moving. So we need to find a way to adjust this X and Y based on this distance. So to do that, we're just going to create a new function, func, and we're going to call it compute position. And what that's going to do is that's going to take its current X and Y and then shift it based on the Z value, the distance away, to shift it either towards the center when it's far away or towards the edge of the window as it moves towards the camera, which is the effect that we're seeing right here. So as it's far away, it's always towards the center. As it moves towards the camera, it actually flies off to the side instead of just simply getting larger because it's not moving directly at the camera. It's actually moving slightly to the left, slightly to the right, slightly above, slightly below. So let's compute that position. So this is going to be kind of a bit of fuzzy math. This isn't the most accurate Starfield rendering simulation. The idea is that we just want to take something, and as the distance increases, we want it to shrink towards the center. And as the distance decreases, we want it to grow towards the edge. So to get that effect, what we can do is we can first let's make a new variable called where it's going to draw. Where to draw the star at. So var draw x equals actually, let's not even do that. Let's just make it return that. So all right, so var draw x is going to be its current x position divided by the distance. So that means that wherever it's at now in its home position, as the z value increases, it will shrink. So if it's at halfway to the right, let's just bring this up. If it's halfway on the right side here, as the distance increases, it will actually shrink to the left, or if it's here, it'll actually shrink towards the right. So that means that bigger Z moves the X to a smaller value. We will then adjust by the window size. So to get the window size, we can just grab that at the start. So let's do this. Grab window size. So on ready, var window size, oops, equals, and then we're going to get the viewport. And then we'll get the size, and we'll just do the X size of it. We'll assume that it's square. We can adjust that later, but we'll just pretend like this is a square viewport rectangle and just use the X value. So we want to adjust this X based on the distance and amplify it by the window size. And what that means is it's basically going to scale from 0 at a large distance, 0, and at a small distance where it's closer to the camera, it's actually going to be 1 window size away. So that means that it will actually traverse farther than it needs to. It'll go from, if 0 is here, this is window size over 2. So window size is going to be, let's say out to here. So it's actually going to fly off the edge. So that means that it won't disappear too soon. It will have a little bit of traversal that we don't care about, but whatever. It'll actually cause a little bit of a delay before it appears back. So it'll give the effect of stars leaving your field of vision and new stars appearing at the back, as opposed to, if you see it jumping back and forth, you'll say, oh, that's just one star hopping left and right. So that gives us our window size. Now this is going to adjust it from 0 to window size, but we want it to start at the center. So we'll simply just do window size over 2, and that means that it's going to start at the center here, window size over 2, scale from 0 to 1. And likewise, it'll scale the other direction from 0 to 1 as well. We'll do the same thing for the y value. So var draw y equals y over z times the window size plus the window size over 2. And so same thing. As the z value increases, it will shrink towards the center. As it decreases, it will fly off towards the top or bottom. We want to go at least one window size away, and we want to start in the middle, which is window size over 2. And now what we can do is simply return draw x and draw y. So this computes our new draw position. So what we can do here is say, okay, let's get that new position. In fact, let's not even do this. Let's do a vector return vector 2 of this new x and y. So now we have a new vector that says this is the position of it. What that means is now in our draw function, we're going to grab that x and y position. So we can do draw position equals compute the position. And then we're going to call that here for draw position. Okay, so what this means is we'll now compute the distance here, draw it at some radius with some color. And so let's see what happens. And keep in mind, it's at 0, 0. Oops. So since it's at 0, 0, and in fact, z here is starting at 0. Let's start it at 10. We want to make sure that we're not dividing by 0. So we need to make sure that once z gets too small, which is when it's really far away, or sorry, when it's really close to the camera, we don't want to hit a 0 value there. So what we can do instead is say, did we go too far towards the camera? And if z is less than, let's say 0.5, which means it's pretty close to the camera, it should be well off the side of the viewport. We just want to reset it, z equals, and then we'll reset it to a large value, and a fairly large value is just going to be window size. So we'll set it back to window size. So that says we've jumped all the way off the edge, which is close to 0. We'll jump to a large number, window size, which says push it really close to, but not exactly in the center, because we don't want them all to start from the middle. We actually want them to kind of start in a pattern, an area that's near the middle, but not exactly the middle. Oh, let's go back to the script. So once we've hit the window size, we also want to make sure that, oh no, that should be all we need to worry about. So it'll get low, and then it'll hit large again, and then we'll update, which will then compute the new location for drawing. So let's draw it. So once again, we're seeing this. Is it even moving? I'm not sure that it is. XZ, let's give it, oh, it's not moving probably because of the X and Y being 0. Yep, there we go. So now we're seeing a little bit of movement. So it's, and then it moves faster, and then see how it hit the edge. Flies off, got far enough, and then pops back in. Perfect. So one thing to note is I think our window size over 2 is a problem. What we can do actually is just get the size and then just do .x and .y. We don't have to worry about it being square or not. .x, and let's see, oops, let's see what happens now. Int and vector2 and operator windows. Let's see what variable we're working with. So let's use the debugger. All right. So window size is an x and y. We want to do window size x over 2. Why am I getting? That worked. Int and vector2 and operator division. In line 28. Oh, this X is Y. No. Hold on 1 second. Size.x, window size.x. Window size is an X and a Y. Let's just move this adjustment off for now, see if that is where the issue is. No, so it's this guy. Oh, here's why. So we got the Z here. So it was actually resetting. Z was being set to window size. Window size is now this. So we'll just do this. We'll do Z will start at the max of window size.x or window size.y. So whichever's larger, Y or X, Z will reset to that. So they're just to make sure that we get a large value, the large value of the two to ensure that we're getting the full range of motion on that. So let's restart. So there it is starting towards the center, moving away faster, 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 and it shoots off. So we can even see just by the persistence of vision that as it starts shooting off, it almost gets a trail by default. And that's just because our eyes, in the way that the monitor technology and the streaming and then everything is working, it kind of looks like it has a trail, but we're not actually drawing a trail. It's just that our eyes perceive it as having a trail. So it's kind of giving us that effect to begin with. But we'll probably add a new trail behind it just to give it a cooler effect than that. So we'll just do this move from the center large z to the edge small z. As we can see, this is with x and y is 10. Remember, if x and y is 0, it actually won't really move that much at all. And so we can show that by switching this back to 0. And it should just stay in the center and not move. So even that with very small values of x and y, we're also going to wind up with a star that kind of barely moves, and then it'll actually start accelerating quite quickly, and there it goes. So the things that are closer to the center fly towards the camera faster. The things that are further to the edge will move at a more steady rate, kind of giving a Starfield effect later once we add more stars. So once again, we'll default back to 0 and 0. We've got the movement here, we've got the update. So the last thing that I want to do before we move on is change the size. So let's compute that new radius. So change radius based on distance. So var draw radius is going to equal whatever the default radius is. But we also want to adjust that based on when it's further away, which is smaller z's, or sorry, larger z's. Smaller away or farther away should be smaller. So farther away here, we can just do radius divided by z. And let's also multiply it by the factor, which we're probably going to have to actually change because I believe these are going to be way too small. Let's see what happens. Oh, we're not actually using it. Radius. That should work. We're still at 0, 0. Let's do this by, I don't know, 100. See what happens. Oh, there it is. And it came way too fast straight at the camera. So we'll do 10 and 10 just because we shouldn't have anything right at the center. And what this will give us is, oh, it's really small, really small, really small. And then it flies towards the camera. So that's almost exactly what we want. Maybe we can go a little bit larger. So we'll do 1 plus, so that way it always has a default radius of 1. And then as it flies towards the camera, it gets larger and larger, and there we go. So now we kind of have something that looks like it's smaller when it's farther away, grows larger as it gets closer, but not too large, and uses this factor to say as the distance gets closer to the camera, we'll grow it larger, just so that way we can actually see it. So this isn't the perfect radius logic. Don't worry about it too much, but some of these funny values will wind up working anyway. So finally, we'll draw that circle. So, okay, this is all I really wanted to do for just the basic star for now. The next thing we want to do is make an actual field of stars. So we're going to go and we're going to make a new scene called a 2D scene, and we'll call it Starfield. So this scene is going to be actually relatively simple. So let's add a script to it. Same name, all of that. We'll save it. And it's going to have a few things. First thing is star count. Var star count equals, let's say we start with 100 stars. That sounds like a good value. Then we want to do is we want to start building a whole bunch of stars. So to do that, first we need to import our star script, the scene that we just made here. So to do that, we'll do const star, and we'll do a preload, and we will preload. We'll load the star scene, not the script, but the scene itself. And that says we're going to, as this scene launches, we'll make sure that we get a star ready to go. Next thing we're going to do is we're going to make the number of stars that we have specified, and we want to make sure that we make them at random positions, random distances. So first, we want to do for star index in range, and we'll do the range star count, just like that. And then, so make a number of stars, and we want to give it 3 random values, x, y, and the start distance. We don't want them all to start at the same plane, because then they'll all sweep towards you at the same time, which won't give you the whole depth effect. So we want to stagger them, some farther away, some closer to the camera. Some will probably even start off the camera, some will start so far away you can't see them. That's fine, because as it loops, you'll get this continuous Starfield effect. So first thing we're going to do is compute random x and y. So var x equals rand, this should be in. Let's wait for this to fix. Sorry, wait for Godot to catch up. All right. So first thing we want to do is compute the x and y. So var x equals rand. We can do a random float, which gives us a value from 0 to 1. And we'll multiply it from the far left of the window to the far right. So it could be anywhere in there. We'll hope it doesn't do 0 and 1. Or sorry, it's completely 0, 0, because that'll be not quite so entertaining, but we'll just let the random number generator take the wheel on that one. So the first thing we want to do is, oh wait, hold on 1 second, let me check something. What we can actually do is not even worry about computing it here. Let's just make the star. So var new star equals, so we'll make the star scene, we'll instance it, and then we'll simply just add child the new star. Let's let the star handle computing its own position to begin with. So in this ready, what we can do is we can actually say, give ourselves a random x and y. To do that's pretty easy. We can do x equals rand range, and it gives you a from and a to value. So from we'll do, because we're going to center it, so 0, 0 is actually going to be the top left. So we'll center it from, we'll do it from negative of the width over 2 to the width over 2. So we'll adjust the origin based on that. So with the random range, we can do negative window size over 2 and window size dot x over 2 to window size dot x over 2. It's the equivalent of negative 1 to 1. And for y, we'll do the same thing. Rand range from negative window size dot y over 2 to window size dot y over 2. So negative 1 to 1, top to bottom, left to right. And we'll also give it a random distance. So remember the distance we were saying, it's from 0, which is really close to the camera, to 1, which is, or not just 1, but the larger of the window sizes, which is going to be, 800 pixels or whatever. So kind of the same thing we're doing here. We'll just take the max from the x and the y and do z equals that value. And with that, we shouldn't actually have to do too much more. So we're going to have the star field, which makes 100 stars. And the star itself says, give a random position, a random distance, and start handling itself. So we're going to hit play now. So we don't have a scene selected first. So we'll go to Starfield and say, this is our main scene. We'll run it and let's see what happens. So, hey, look at that. We've got a bunch of stars. They're flying towards the camera. They are pretty spaced out. And as you can see, the distance, they're all appearing at once in a wave. So it actually shouldn't be just the max of these two. It should be a random range. random range from 0 to this value, saying start at 0 or whatever the largest distance is and do some value in there. So, oops, let's hit play. And now we can see, oh, look, they're staggered. They're kind of coming at us. There's a little bit of a gap here. They're not all appearing at the top and the bottom, but they are stretching all the way to the left and right. That's good enough for now. And they're flying towards us. So one thing I see is I kind of like a few more stars. So let's actually do 250 stars. Don't worry, these objects are all really simple. So 250 of them is pretty easy for us to handle. Now, as you can see, I adjusted the size of the window. So they're actually kind of flying off towards the corner. If I bring it back down to the native size of it, it actually looks more accurate. So they're not quite going all the way to the center here. So what I might actually do is instead of just doing the window size here, let's do this. On ready var max distance equals this times 2. And then instead of computing it every single time, we'll just do anywhere from the max distance. That should give us a pretty big number where they will start closer to the center. Let's run that and take a look. So see how there's a lot more densely packed here in the center. And then they start to fly off. You will notice that we're seeing a lot of pop-in. That's just because I did give it that default value of 1. Maybe if I give it 0.1, then as they appear back, they're much smaller, farther away. It's kind of hard to tell when they pop in. And then they fly towards the camera, just like that. So let's make a move a little bit faster as well. 3. Try that. And now they're flying at the camera. So they're all moving the same speed. Another thing we could do is give them random speeds, but we'll worry about that later. But overall, we've got stars flying towards the camera. Get closer, and then they appear back at the start. I might even try just getting rid of this 0.1. Let's see what, oops. Let's see how it looks like with that. Try one more time. So it's not making much of a difference. They're all still pretty far away, and then they fly towards the camera, just like that. See, many of them are flying way off to the side, a little far away. They could be a little bit larger, but I think once we add the trail, they'll actually look better. So let's add that trail. So the question is, what is a trail for the star? So even in this example, there's not actually really a trail. It's just drawing several of them. I don't really like that terribly. You can see there's a gap between the trail and the head of it, just because it's drawing a series of circles that kind of fade away. What I would rather do is draw a line from whatever its previous position was to its current position. And so that kind of gives you this effect of motion a bit more than just fading away this a series of circles. So let me just review this real quick. Basically what we're going to do is say, well, we have the current x and y. We can just track the previous x and the, oops, that's not what I want, and the previous y, and say, okay, track previous position for the trail. Let's just call it a tail, because that's more fun. So whatever the previous x and y were, we're going to take that and draw a line from the previous to the current. So here we have the current draw position. What we can then do is say, let's draw the trail first, just so, although it shouldn't matter, but we'll just draw the trail first. Draw a trail from the previous position to the current. And so draw line, and previous position is simple. We'll do vector 2 of previous x and previous y. The 2 we already have, that's the draw position. The color, simply we'll do maybe not completely white, just so we can tell a bit more. Let's do 0.5, or let's do 0.75, 0.75, and 0.75. That kind of gives us a bit more of a gray for the trail, whereas the actual star itself will be white. We'll leave the width at 1, and all the other default parameters can stay the same. So first we draw a line from the previous position to the current position at a slightly darker color. Then we draw a circle on top of that. So if we draw this, we're actually going to see a weird effect where the lines all draw out from the center. So as you can see, this is its default position flying up and there. So that's because we're not updating the previous value. So what we can do is on every frame here, we can say before we worry about drawing anything, let's first update the previous position with whatever we compute as the current position. So um, update previous position. So new position equals compute it, and then we can do prev x equals new position dot x and prev y equals new position dot y. So let's run that. So it's still a little hard to tell. There's a bit more of a trail behind them, but honestly, that's because it's moving so fast. What we can do is actually hide the circles for now, and we'll see what kind of a trail we're seeing. And let me see if there's anything showing up. Not quite. Let's try making the line a little bit thicker. See if that helps. Not seeing anything. So that's probably because the previous position is really close to the current position. So the lines it's drawing are really short. I think we can do that by increasing the speed a lot. Let's just increase the speed a lot and see if that's true. Not seeing it. Oh, you know why? It's because every frame we compute the new position after we adjust the position. So they are the exact same number. So let's draw the new position or compute the new position first and then move it forward. So we get the previous position, move the star, and bring it up. So here we go. So now we're seeing just the lines. And I'll explain this little flashy effect we can see, but here we're seeing just the stars being drawn as lines, not even with the circles. So it almost looks better without the circles. Let's try it just with the lines and the circles now. As we can see there's a little bit of a head to the star, and then they have their own little trail. So that's looking great. But we're seeing this kind of flashing effect, and that's because as we hit the edge, we teleport the star back to the maximum distance away, but the previous position was still up here, so it's actually drawing a trail as if it jumped from here back to the start, which is this line of it flashing. So these lines are actually the stars teleporting farther away. So we can solve that pretty simply, is just when we move the z distance farther away, we can just recompute the same distance so that for one frame we won't draw the trail, but that frame is it really far away anyway. Oops. And we won't see it in the first place. So let's go take a look. So here we go. There's no more of those flashing. We get a little bit of a trail, especially for the ones that are further away. And then as it grows closer to the camera, we can see the head of the star. So hey, look at that. We've got our Starfield effect. For the sake of clarity, let's just make this a different color so we can watch. So you can see there's a little bit of a cyan effect to the stars, but the white is the trail of it. So we can tell the difference between the trail and the stars. So there you have it. We have our star object, which just has a position, a previous position for the tail, a distance away, and a speed that it moves towards the camera. A radius and an arbitrary factor to determine how big to draw of a circle to show the star. And then we just grab a few window sizes to make sure that we're adjusting everything to the correct distance of the window. Then when we create the star, we say give yourself a random X and Y home position and a random distance on that home position to say you're starting here, but you're going to be moving across some sort of a illusion of 3D line towards the camera, and you're going to start somewhere along that line. And then we say, let's process every single frame to make sure that we can adjust ourselves and redraw. To compute the position, we just take whatever its home position is, shrink it towards the center for distances that are far away, move it towards the edge for distances that are close, adjust it in half by the window size, and also, offset it by the window size over 2, and then also give it the entire window size for it to grow across. Same thing for Y, and we'll return that value. Then every single time we update on the process, every single frame, we compute the previous position based on wherever it is currently. That's useful for the trail. For the tail, let's just do that. Then we change how far away it's moving from the camera. So remember, we're starting away, we move across some speed, and we adjust by delta so that way the frame rate doesn't change how fast the stars actually move, because then on a higher hertz monitor, you're going to see different speeds as opposed to, an older machine that runs a little bit slower. And then we adjust the distance there. Finally, if we get pretty far away from the camera, we're probably going to be off the edge. So that's why we're going to check if we're pretty far away, which is a very small Z value. Then we're just going to reset and make sure tails don't jump. And that makes sure that we jump back to the far away value and then come back towards us. And then finally, we update the drawing of the star just to make sure we draw a new circle, draw a new tail, and all of that. The draw function is also relatively straightforward. We just get the current position of it. We compute how big of a circle to draw, and then we say draw a line from the previous position to the next position, and also draw a circle from whatever the current position is. So that way we can kind of see a star grow, but we also get the line to give that sort of motion effect that we're looking for. So that's the entirety of the star. And then really the star field is all it's doing is it's just making a whole series of stars. It's not doing anything smart. It just wants to grab some stars and create them. And the stars take care of everything from there. So yeah, that is your Godot Coding Challenge Episode 1. I hope it gave some insight as to how to do basic drawing, how to get scenes loaded and imported by other scenes. I hope it kind of gave you an idea of how to move things around in 2D, but remember, we're not using the Node 2D properties for this. We're simply just taking the Node 2D's CanvasItem parent class and using that to draw with this draw function. One thing to note, make sure you have the underscore draw. If you have the function name incorrect, this update won't actually call your function. That can be pretty frustrating to figure out why your draw function is not being called. So just always make sure to double check that. And once again, all of these function calls can be found in this CanvasItem documentation. The easiest way to find that is do something Godot CanvasItem. That will take you to this documentation. You can also do something like Godot draw circle. Oops. And that will give you this custom drawing in 2D tutorial, which is very helpful. Kind of goes over most of the topics I've covered here, with a few things like how to draw arcs, colors, even how to draw things like vectors of points, which allow you to get polygons and everything ready to go. But it also has links to the CanvasItem documentation we had here, which has all of these functions available for you to give you ideas of how you can draw things by hand. So we're not using any sprites. We're not taking advantage of any of the drawing functionality that the engine gives you other than these basic draw line, draw circle calls. And as always, I highly recommend you check out the coding challenge or the original video that this is based off of. Very helpful, very cool idea of trying to take what's happening in this sort of different environment, this JavaScript and processing environment, and say, how can I redo that in Godot? So highly recommend you check this out first, or check it out again if you haven't already. Always have your documentation up, and make sure that you don't copy and paste any of the code here. It's best for you to type it in yourself. You can either follow along in the video, or watch the video once, do it yourself, and then come back and review the video, or even just forget anything I've showed you, look at this and say, what's going on here and how can I make it happen yourself? So I hope this was helpful. If you found this helpful, please give a like or a subscribe or leave a comment. If you think of any cool other ideas for me to implement on this, let me know in the comments below. Hopefully I'll probably be following most of the coding challenges here, but there's already a few ideas that I've got for, hey, these challenges are great for processing P5 JavaScript, but Godot has a few other things that we can try out and a few other derivative coding challenges that we can come up with. So if you have any cool ideas, let me know in the comments or send me a message. And hopefully I'll be able to find the time to make a few of those as well, because Some of these processing things are going to be a little bit different than the Godot ones, and so it's kind of cool to explore what we can and can't do in Godot and how we can make things a little bit different and accommodate what the engine is doing here. So yeah, please help out people who are learning by sharing this, and if you have any more feedback or if there's anything you'd like to get covered, let me know. All right, bye.